In this word sum, we have the following information. My grandson is about as many days as my son is weeks, and my grandson is as many months as I am in years. So you can see that we are working with years, ages in years, ages in weeks, and ages in months. So let's use that information and then just read a little bit further where they say, my grandson, my son and I together are 100 years old. Can you tell me my age in years? That's obviously then grandpa speaking. So what we need to do is to assign variables and possible values to the three people in this word sum. We can start by saying we've got grandpa, we've got his son, and we've got the grandson. So let's say the grandpa is X years old, and then we can say that the son will, for instance, be S years old, and the grandson is G years old. And then we can look at the son and say, since he is S years old, that means he will be 52 times by S weeks old, and he will be 365 times by S days old. And then for the grandson, we've got, since he is G years old, it will be 52 times by the G weeks that he's old, and he will be 365 times by G days old. However, if we look at the fact that we also have months, we can also modify that to say the son is 12 times by S months old, and the grandson is 12 times by G months old. And now we've got information that we can work with, but we have to go back to the word sum to put all of that into context. So starting with the fact that the son is 52 S weeks old, and we go back to the story sum, we can see there that the grandson is as many days as the son is weeks. So we know that the son is 52 S weeks, and the grandson will be 365 times by G days. So there's an equation. 52S is equal to 365G. Then we also have, going back to the story sum, my grandson is as many months as I am in years. So then we know that the grandpa is X years old, and that is equal to 12G months of the grandson. And then we also have the last line where they say grandson, son, and grandpa together is 100 years. So we can then say X plus G plus S is equal to 100. Which essentially means what we have now are three equations with three variables. We've got S, G, and X in three equations. So let's call that equation number 1, equation number 2, and equation number 3. And since we have three variables, we will need to do simultaneous equations with the three equations. And we can start by saying, since we know that X is equal to 12G, we can just substitute it into there and form a new equation. So this new equation will then look like this. It will be 12G plus G plus S is equal to 100. And let's call this 3A, since it came from equation number 3. And that will then give us 13G plus S is equal to 100. And then working with equation number 1, just modifying that, we can say that S is equal to 365 over 52G, because we can literally just divide both sides by 52, since it will then cancel out on the left hand side. All that we are left with is 1S, which is perfect, and it's fine. So we can then take that, since this is still equation number 1 really, we haven't modified or did anything to equation number 1, apart from the fact that we've just wrote S as the subject of the formula, but that can then be substituted into that S. However, what we can do to make life easier is to take equation number 3A and just rewrite it as S is equal to 100 minus 13g. Just taking that 13g across to the other side. And then we take that s and we make it equal to this, which is then 365 divided by 2, which means, if you look at it there, s is equal to 7,019g. That's the answer of that division. But working with such decimals in terms of a story sum is not always ideal. So let's round this to s is equal to 7g. So in that s, we can then say 7g is equal to 100 minus 13g. And there we have a very nice linear equation with one variable. So just taking the 13g across to the left-hand side by adding on both sides with 13g, we find that there they cancel. On the left-hand side, we've got 20g is equal to 100. Then we divide both sides by 20, and what is left is, since the 20's cancel, g is equal to 5. Now remember, g was the grandson's age. So now we know at least that the grandson is 5 years old. Then we can go back and say, but s is equal to 7g. So the son is equal to 7 times by 5 is equal to 35 years old. And then we can go to that one over there where we've got that x is equal to 12g. And we can say that since g is 5, this is 12 times by 5 is equal to 60 years old. So then, having the three ages, we can say grandpa plus his son plus his grandson is 60 plus 35 plus 5 is equal to 100 years. And there we have it, all three of them in their ages. Although the question only asked for the grandpa's age, we actually have all three of them as a way of testing the accuracy of our data. But just before we conclude, go back to the original question and look at that word over there. My grandson is about as many days as my son is weeks. That is a bit wishy-washy in terms of mathematics, but if you just go back to that division over there and the answer that we got over there, if we didn't use the rounded down value of 7, but the value of 7,019 in S, when we multiply it there with 5, what you'll get is an answer of 35,05 years, which equates to 35 years and about 18 days, a couple of hours into the 18th day as well. So it's 35 years and 18 days that the age is given of the son. But because of the 18 days and the fact that we are really only working with ages in terms of years, you're either 1 year or 2 years or 3 years old, very seldom would people say you are 3 years and 18 days old. So that was why we could round it down to 7 and not use the 7,019, because the age of that son is still 35. It's going to be 35 until he becomes 36. So that 18 days is very accurate, but it doesn't have to be that accurate in the context of ages, and that is why that word was used. We can round down even though it is not 100% accurate, just because of the context of the ages in years.